Hi, this is a recent video for the Mathization ebook. This is the page in the book itself, and I describe it's about thermal conduction. And in this example, it's when you combine two masses at different temperatures, what's the resulting temperature of the combined mass. So that's described in this book in more detail, but I'm going to give you here on paper what you can do like at home. I did do this with a thermometer in containers of water and a cup of water, and one had 4 cups. These were tap water. Of course, you can heat one more if you want to, and then have a greater difference in temperature for the experiment. Volume 1 is 1 cup at 63 degrees Fahrenheit. Volume 2 is 4 cups at 114 degrees Fahrenheit. I'm gonna go back here. When these two volumes of water are combined, what is the resulting temperature? We do not need to know how much energy is in each container, like the amount of joules, which has to be calculated, which the average person wouldn't want to do or doesn't even know about. And we can rather use temperature, which is directly related to the amount of energy. See, energy and temperature are related directly. If temperature or energy doubles, temperature doubles. If the temperature was half, that means there's half the energy left. Thermal energy, that is. Let E equal thermal energy or heat instead of joules of energy. We'll also use volume instead of mass, the amount of material. We'll just use the volume of material, and it's water. And since mass and volume are directly related, that is, if you double the mass or amount of a substance, you would also double the volume, and vice versa. Okay, for this system, the total thermal energy is right here. Of course, we're using temperatures instead of joules as the an energy of each volume of water is calculated as the volume and the temperature. See, total thermal energy available at the start is the energy in the first volume, and plus the energy in the second volume. So, and energy in the first volume is the volume times its temperature, and energy in the second volume is its volume and times its temperature, the product. So kind of like thermal mass. Okay, product. Okay, so we have ET, total energy, is 1 times 63 plus 4 times 114, and we get 63 plus 456, and we get 519, which you can think of as joules of energy as the units, but it's really the temperature mass or temperature volume product. It's still okay to use. And here, when the volumes of water are combined, they will also have that total amount of energy. When you can mix them together, so the volumes will be 1 and 4, and that makes 5. And the total energy is the total mass or volume times the temperature, equilibrium temperature. Yeah, when they're combined, it's like at equilibrium. It'll be an equilibrium state, and at what temperature, you know, the resulting temperature. Okay. So we have energy total is 519. Mass or volume total is 5. Well, I could put VT here to make it better. Volume total is 5 times the temperature of equilibrium. Solving for equilibrium temperature, it is divide each side here by 5 and that side by 5, and then get this, and the result of that division is a quotient of 103.8 degrees Fahrenheit, which is about 104 degrees Fahrenheit. It's a pretty good experiment to do, you know, at home with water and like thermometer, house thermometer that you see like from Dollar Tree or something. Okay, thank you.